people, students, lovers of chemistry out there. I'm super excited to be here with each and every one of you on today's episode, with which we're beginning an entirely all new series. And by the way, I want to say a very big thank you to each and every one of you subscribers who have engaged with my channel and space thus far. It's been a joy serving you with my potentials, gifts, and all that I have inside of me. Because of you, we've been able to hit a landmark of achieving 50 subscribers. I want to say a very big thank you to you. And for everyone who is watching this video right now, who is yet to subscribe, I implore you to please do so, because we have a whole lot of valuable stuff coming your way. Alright, today's episode is going to be the beginning of an all-new series called The Introduction to Radioactivity. So I'd like you to just sit back, relax, and enjoy every bit of what we have for you in today's video. By way of introduction, let's first define what radioactivity is. Radioactivity is actually a process through which certain unstable atoms, take note of the word unstable, they break down and or decay by releasing energy in the form of radiation. Now let's use a concept you can relate to. Over here I have the diagram of someone who is on a chair that is quite unstable because one of the legs are broken. So imagine a classroom chair, for instance, has a wobbly leg. That makes that chair to be unstable, and if nobody fixes it, it will break because nobody has fixed it and it is unstable. Now, atoms that are radioactive are much like that unstable chairs. Now, watch this. Some atoms in nature are like that chair. They are unstable and they will break down on their own. But instead of falling to pieces like that chair we just saw now, they release invisible energy. That energy is called radiation. In the case of that chair, we saw that the chair broke down because it was unstable. But in the case of atoms that are unstable, they release invisible energy. That invisible energy is called radiation. So the process through which unstable atoms release energy is called radioactivity. Now this happens inside the nucleus of an atom, and it leads to the formation of a new, more stable atom. You see, the concept of radioactivity is all about unstable atoms releasing radiation to become stable. Now on the screen right now, I have an example you can also relate to. Here is a boy that is feeling pressed and urgently needs to use the toilet. Now in that case of needing to use the toilet, he can be said to be unstable or uncomfortable. There is no position you will put him in that he will be stable or comfortable. He won't be able to sit down comfortably, lie down comfortably until he uses the bathroom and he releases, whatever it is that is bothering him. That process of releasing the stuff inside of him makes him to now become comfortable and stable. You see, radioactivity is just like that. When atoms become unstable, they need to release that instability by releasing radiation, and then they become stable after that is done. I'm sure you understood everything we just said thus far. So here is a brief history into the concept of radioactivity. What really happened? How did we come about this concept of radioactivity? Well, let me keep down my teacher's hat and put on my storyteller hat. Story. Once upon a time, it all started on a cloudy day. You see, it was in the late 1880s, okay? And at that period, they had just discovered the concept of X-rays, and it was discovered by the scientist called Henri Becquerel. Now, X-rays had just been discovered in the late 1880s, and it was fascinating everybody because, let's face it, any new thing that is found in today's world becomes the rave of the moment. Everybody wants to know about it. Everybody wants to be part of the trend. So in the late 1800s, the trend then was X-rays because they had just been discovered, and they had been discovered by Wilhelm Röntgen. I made a mistake. It was not Henri Becquerel who founded it. It was William Röntgen. So these rays could pass through human flesh and create images of bones. It was quite mind-blowing stuff at that time because we had never seen anything quite like that. So it was something that just caught the attention of everybody. So one curious scientist, and that's the stuff about scientists that I love a lot. They are curious people who like to make research. So one curious scientist by the name Henri Becquerel wanted to test something. He wanted to see if sunlight could cause a similar effect, because how X-rays work is that powerful rays of light are sent through your body because they can penetrate the human flesh, and then your bones absorb those rays of light, and because they absorb those rays of light, they are able to project images that can be captured by the X-ray machine. So Henry Becquerel wanted to see if the sunlight could cause a similar effect. So what did he do? He took a type of crystal called uranium salt, and then he wrapped it in black paper along with a photographic plate like the early camera film. What was his idea? He wanted the sunlight to shine on it to see if radiation will appear on the plate and if an image will be formed. Instead of X-rays this time, he was using the rays of the sun as the source of light. So that was the experiment he was carrying out. But there was one drawback. Okay, it was a little twist. What happened was that day was a cloudy day, so he didn't have access to so much sunlight. And because of that, he didn't bother exposing the materials to the sun. He left the wrapped bundle in a drawer. So after some days, he developed the photographic plate to check if any images had been formed. And wow, an image was there. There was no sunlight, no external light. Remember, he wrapped the bundle in a drawer where light did not have access to it. And there was no external light, just the uranium salt giving off radiation on its own. If an image was formed, it simply means that there was a light source or a radiation source coming from somewhere, and that radiation had to be from the uranium salt that was locked up in that drawer. So what was the implication of that discovery? It simply meant that those uranium salts or the uranium atoms contained in that uranium crystal salt were releasing energy without any help from outside. That was the birth of the concept of radioactivity. Atoms releasing energy on their own in order to become stable. And this was the first experience of such a concept that was ever recorded in the history of science, and it was experienced by the scientist Henri Becquerel. So now, after this happened, we have a power couple that now came into the story. I'm sure you're enjoying my story thus far. If you are, please like this video, share, and subscribe. So after Becquerel's unexpected discovery, a brilliant Polish scientist by the name Marie Curie, along with her husband Henri Curie, decided to dive deeper. They decided to make more research on what was happening. So what happened after this? They decided to dive deeper in their research. So Marie in particular was interested in these invisible rays that were projected by radioactive atom, and she called this behavior radioactivity. Remember, we defined it to be the process through which unstable atoms release energy in the form of radiation. So the first person to actually use that word when she noticed this behavioral pattern by some atoms was Marie Curie, and she called it radioactivity. It was a word that she invented. Now, through painful and meticulous work, it was actually literally painful because they didn't know that radiation was harmful to the human body. The Curies discovered two new radioactive elements. They discovered polonium, which we have over here, and polonium was named after Marie's home country, Poland. And then they discovered radium. Radium was actually gotten from the Latin word radius, which means ray. And you know what a ray is? A ray is actually a broken piece of light. For instance, let's say you just wake up early in the morning and you open your windows, you see rays of light coming in. Those are the parts of light that we're able to have access to your room. So that's the history about how polonium and radium were discovered. Now, here's an amazing fact. Did you know that in those days they extracted radium from tons and tons of a mineral called pitchblende, and they were using their bare hands? Because in those days they were not as informed as we presently are in today's world, and they were using their bare hands and simple tools that they had access to. It took months just to get a tiny bit. So you can imagine how much of hard work was invested to get just a tiny bit of the radium element. Their work also proved that radioactivity wasn't just a property of uranium, although the first ever element that radioactivity was discovered with was uranium. Alright? But other elements could also behave the same way. This was a huge breakthrough in the atomic science. So what happened after that? There were some rewards and risks that came with everything that happened. First of all, Marie Curie became the first woman to win a Nobel Prize, and she became the only person ever to win two Nobel Prizes in two different fields of science, physics and chemistry. So much for someone who was just a lady. But the price was actually high. She paid a very high price for it. She and her husband Perry handled radioactive materials daily with no protective gear. So they were actually exposed to so many health hazards. And because no one knew at that time that radiation could be dangerous back then, so all they were using was their bare hands with no protective gear. And then what happened was a crazy fact. Marie Curie's research notebooks till today are still so radioactive that they are stored in lead lined boxes. In fact, you need protective gear just to read them today. That tells you how powerful radioactive materials are. After a long and protracted period of time, radioactive materials still retain that property of being highly radioactive. You can imagine from that period up until now, they're still as radioactive as they were. So here is a summary or a timeline summary for you to easily recall the events that lined up onto what we have today. First of all, in the year 1895, Wilhelm Röntgen discovered X-rays. William Röntgen discovered X-ray. In the year 1896, Henri Becquerel discovers natural radiation from uranium. That was the first experience of radioactivity that we saw. And then in the year 1898, Marie and her husband Marie Curie discovered polonium and radium. And in the year 1903, Becquerel and the Curies, that's her husband Marie Curie and Marie Curie, win the Nobel Prize in physics. And then in 1911, Marie Curie wins a second Nobel Prize. This time, she won it in chemistry. So all that I have said just now was just a story about the introduction into radioactivity. Why does this history actually even matter? This story shows us how, number one, scientific discoveries often happen by accident. Sometimes you're not even looking to make a discovery, but because you are in the field of science, discoveries sometimes are the ones that come to you. Discoveries are sometimes are the ones that discover you, not you even discovering them. For example, we have the story behind how gravity was discovered by Isaac Newton. It was said that he was sitting under a tree, and then after a while an apple fruit fell down, and he began to think, why did the apple fruit fall down and not go up? And then the rest, they say, is history. It happened not intentionally, it happened by accident. Second thing is that curiosity leads to a world of changing knowledge. All the scientists that I just mentioned had one thing in common. They were very curious people. Curious people who were willing to take a step to discover new things. So the study of atoms began not in giant labs, but with simple tools and with big questions. Remember, we stated that they were using their hands, their bare hands initially, and the small tools that they had access to. So now that we have talked about the history of radioactivity, let's talk about the kinds of radioactivity that we have. That brings us to the concept of natural and artificial radioactivity. You see, there are two types of radioactivity based on where it comes from. Radioactivity can be gotten from two sources. Okay, we have the natural radioactivity first of all, and natural radioactivity talks about the radioactivity proceeding from elements that are found in nature. For example, like uranium with the mass number 238, or carbon with the mass number 14. These atoms are unstable and by themselves they decay naturally over time. Now, what is the connotation of this? A very good example is the carbon that is found in your body. You see, the carbon found in your body contains a tiny bit of the radioactive carbon with the mass number 14. And what is the implication of that? Scientists are able to use it to date fossils and ancient bones. This is where the concept of something called carbon dating comes in. Now, you may not have heard this. For some of you watching this video, you may have heard this before. Okay, but whether or not you have heard this, we're going to go into the concept of carbon dating as we proceed in this series of radioactivity. Now, carbon dating is the process of using radioactive techniques to find out the actual age of substances that contain carbon inside of them. And one of the substances that contain carbon inside of them is the human bones, which is why a bone, maybe from a prehistoric creature like a dinosaur, can be found by scientists. And then through the process of carbon dating, they are able to say, oh, this bone is 1 million years old. And you watching the channel from maybe the comfort of your home might be thinking, how did they know? It was through the process of carbon dating. All right, so now that we talked about natural radioactivity, the next type we have is the artificial or man-made radioactivity. All right, so this is the kind of radioactivity that happens when scientists force stable atoms to become unstable. A stable atom is there, but because of artificial processes, scientists force it to become unstable. And because of that, they use machines like nuclear reactors to cause this instability to unfold. This is often used in medicine and in energy production. A very good example is the cobalt element with the mass number 60. It is actually made and produced in reactors and used in hospitals for the treatment of cancer. Now, in the world of medicine, when they are treating terminal diseases like cancer, you may have heard about words like radiotherapy and then words like chemotherapy. These are actually medical processes that use radioactivity, utilizing special elements like cobalt with the mass number 60 in order to fight diseases like cancer. We'll go into more details as we proceed. Just thought to bring that to your view. All right, now that we have talked about the types of radioactivity that we have, let's talk about some everyday examples of radioactive materials. Okay, this is just the surface. We are just scratching the surface in today's video about radioactivity. Now, you might be surprised that radioactive materials are all around us. They exist in places that you might not even imagine. And here are some common examples. Number one, we have the smoke detectors. Okay, smoke detectors actually contain the radioactive element called americium. Americium with the mass number 241. Now, the presence of these elements makes smoke detectors to be able to detect smoke in the air. I'm sure many of you never knew about this up until now. Next example we have is something you eat probably every day, if not every day, maybe every week, but at least you eat it once in a while. Is the banana fruit that we have. Bananas are actually radioactive because they contain the element potassium with the mass number 40. Now, somebody might be thinking, oh, bananas are radioactive. I'm not going to eat bananas again. Calm down, okay? The level of radioactivity that is present in bananas are actually very, very small and tiny. In fact, it is at a harmless rate or portion, okay? So bananas are actually very healthy for you. Next item that we have that is a radioactive materials are the granite countertops you have in your kitchen. These granite countertops actually have traces of uranium that are found inside of them. Okay, so when you see a granite countertop, just know that you are looking at a substance that is probably containing a trace of uranium, which is radioactive. Who would have ever thought that your kitchen will contain radioactivity of some sort? Next radioactive element that we have, or item that contains radioactive elements, is the medical scans. that we use. These actually use X-rays. Now you can see on the screen right now, I have a picture of a medical X-ray scan that is being used over here, and it is made possible through the element called titanium. Titanium actually is a radioactive element with the mass number 99. This M over here stands for the word metastable. Okay, we're going to come into more details as we proceed, but the use is that it helps doctors to see inside your body. All right, so now that we've talked about some of the examples of radioactive elements that we have, the final example that we have is the old luminous watch dials. Now I'm sure you must have come across some watch dials that shine in the dark. Now the element that makes it to happen is called radium, and it was used in the past, no longer so much in vogue in today's world. And its use was that it glowed in the dark. Now, I want you to note that most of these elements that we mentioned, okay, they give off very low levels of radiation and they are not harmful under normal circumstances. So I don't want you to be scared about using any of these things. So here is a quick recap about all we've been saying since the commencement of this video. First of all, we defined what radioactivity was. We said it was the process through which unstable atoms release energy in order to become stable. It was discovered by Henri Becquerel. Henri Becquerel discovered it, and Marie Curie expanded his work. And then we talked about the types of radioactivity. We have the natural radioactivity talks about the radioactivity found in nature. Artificial radioactivity talks about the radioactivity created in labs or in machines. And we have some examples around us. We have smoke detectors, bananas, medical scans, granite, and so on and so forth. If you stuck around till the end of this video, I want to say a very big thank you to each and every one of you who have made my channel a delight to relate with. I look forward to seeing you in the next episode, where we're going to be diving deeper into more concepts of radioactivity and solving some questions that we'll come across. Up until then, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. I will see you in the next video.